Okay, I'm going to skip over this stuff, but if you want to look at this material on Hume, this is about the passage of Hume's that Appia quotes. You can find it in the study questions. But right now I want to turn to this example. So this information actually comes from section 4.3 on page 132, the second half of page 132. Appia has this example where purple petals are dominant over, or the gene for purple petals is dominant over the gene for white petals. And since that's the case, we can take a plant that has purple petals and breed it with a plant that has white petals, and we'll get either this first situation here, and this situation arises if the plant that has purple petals has two genes for the purple petals. And since the gene for white petals is recessive, in order to have a plant that has white petals, both copies of the gene have to be white. So if we're breeding two plants like these here, then what we'll expect to get, or what we will get in the second generation, is a series of offspring that all have one gene for the purple petals and one gene for the white petals. But because the purple is dominant over white, all of these plants will in fact have purple petals. Or it can be the case that we're crossing one plant that has purple petals, but that plant has one gene for purple and one gene for white. And so here our two plants in the first generation would look the same as the two plants up here, but one of them would have different genes, and so consequently that would affect the offspring. Here we would have half of the offspring that have purple petals, the purple petals because they have one gene for the purple petals and one gene for the white petals, and half the offspring would have white petals because they would end up with two genes for the white petals. Okay, so just using this information here, we can put together an argument like this. And I've simplified it a little bit. So in our premise here, we have every time in the past that a homozygous plant with purple petals, so here we're just looking at the case where, actually let me finish reading it first. So every time in the past that a homozygous plant with purple petals has been crossed with a plant that has white petals, 100% of the offspring have had purple petals. So here we're just looking at, to simplify things, we're just looking at this case here. So however we know it, we know that every time we're looking at plants here that have purple petals, but both the genes are P's, or both are genes for the purple petals, and of course in order to have a plant with white petals, both of the genes there have to be genes for the white petals. Okay, so every time in the past that this has happened, I've gotten 100% of the offspring have had purple petals. Okay, so we know why that's likely to happen. And so the conclusion that we can draw here is that all genes for purple petals are dominant over the genes for white petals. And so the idea is that this is the type of argument that Mendel would have had to have put together in order to draw this conclusion about at least these genes being dominant. He would have collected all this type of evidence, and then he would have drawn a conclusion like this one. Or we could also phrase the conclusion as I have it down here. Genes for purple petals are always dominant over the genes for white petals. That might be a little bit more natural of a way of saying it, but this conclusion here has the all A's or B form. Okay, so in what sense is this an ampliative inference, and why is that a problem? So here, if you flip back to page 160, you can see at the very bottom there that Appia is saying the major problem with the sort of inference that is involved in induction is that unlike deductive inferences, which are logically valid, for inductive inferences, the conclusion says more than the premises. We call such inferences ampliative because they amplify or go beyond the premises. And he says more about that on page 161. But in any case, that's one of the sort of core features of inductive arguments, is that they always, the conclusion always says more than the premises do. So there's always, of course, the possibility that that extra bit that we're saying is going to be wrong, in which case, which is just to say that our conclusion will be wrong. Okay, and lastly, let's look at this argument here. So here we have premise 1 is the same as previous argument, and the conclusion is also the same. All genes for purple petals are dominant over the genes for white petals, but in this argument we've added this new premise. So we have a premise 2 here, and this premise says the way things have been in the past is how they will be in the future. And this is, as you can see on page 160, the principle of the uniformity of nature. Now, when we add this new premise, when we add premise 2 here, the argument is actually no longer an inductive argument. Now it is the case that if these two premises are true, so if, every time I breed these two plants, or these two types of plants, I get all offspring that have had purple petals. So if every time I've done that, I've gotten this result, and the way things have been in the past is how they will be in the future, then I actually do know, or then it does have to be the case, it is guaranteed, that the genes for purple petals will always be dominant over the genes for white petals. So now this is no longer no longer an inductive inference, it's now a deductive inference. The problem, of course, is what the heck's going on with this premise 2. Is it reasonable or fair to just insert this premise into our argument? I'll let you see what Appia says about that on page 160. And you can see there that he and a lot of people have agree about this, that including this premise 2 isn't going to really solve the problem of induction.